Hello, this is A Squared, the webmaster and author at mathandstuff.com. I'm here to talk about fractions. All the material on this site is free, downloadable, editable. You're welcome to use it. I'd like to go to the site and show you what we're talking about today. This is the home page for mathandstuff.com. We will be talking about some of these things later, but for today, we're just going to go down to the bottom link, and I'm going to hit it, and it'll take us to mathandstuff.com on video. We're creating a video and teaching a lesson on fractions or going over a lesson on fractions. There's the page. Originally, it was written for remedial college. Now it's used for Calc 1, beginning sections with limits. So I'm just going to go through the page, but first point out to you that there is a PDF of this page and it's being turned into a video. So what's a fraction? It's a ratio or comparison of two different numbers. On the top, you have the number of pieces involved in the fraction. And on the bottom, you have the number of pieces in one whole. This circle is one whole circle. It's divided into 4 pieces. So there's a 4 on the bottom. 4 is the number of pieces in one whole. Only one of the pieces has been colored, so it's 1/4. This is 2/4, 3/4, 4/4, and so on. Sometimes the fraction is greater than 1. In this picture, you have 2 complete circles shown, and they're in halves, but only 3 halves are colored. So you have 3 half circles, that's 1 1/3 circles. Next thing I'd like to talk about is the fact that it's really important that you put your numbers in the right place. The top tells you how many pieces you have under consideration. The bottom tells you how many pieces there are in one whole. In this picture, we have 1 circle. 2 out of the 3 pieces are colored in. In this picture, we have halves in the circles. We have 3 halves, so we have 1 1/2. Another example. This time, there are 5 pieces in the circle, so it's fifths. We have 2 pieces shaded, so that makes it 2/5. If we'd flipped it and written 5 halves, we would have had 5 pieces, each of them half a circle. Those are the easy ones. Now we get to ones that confuse people a little bit. So if it's too much, just take a break and come back. In this case, we're looking at one fraction. The fraction is 2 divided by 3/5. 2 is the number of pieces we have, the number of whole pieces. 3/5 is the size of one whole. The size is in the denominator. in these pictures, this one's empty, so it's probably the easiest one to talk about. You can see that what was done was to take a circle, a whole that was divided into fifths, and only use 3 of those fifths. So each of these pictures, one whole is 3/5. So I just wrote a bunch of them. Now we need to write 2. 2 in terms of fifths, 2 is 10/5. So in our picture of the 3/5 as a whole, we have to put in, we have to shade 2 whole pieces. That's the same as 10/5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/5 are now shaded. Notice I have one whole circle or one whole piece, one whole piece, one whole piece, and one partial piece. I have 3 wholes and 1/3. And if you've done it with just regular computation, when you divide by a fraction, invert the bottom and multiply, flip and multiply, take the reciprocal and multiply. So our graphic picture makes sense relative to the computation most people know. Now, why did I go through all that? Because I wanted to talk about zeros. Zeros in fractions. 3 different types of fractions exist. Fractions in which zeros on the top, 0 pieces, and some number of pieces in a whole. Or a fraction where there's some number of pieces, but you're dividing by 0. How can you do that? Another case, and this is where Calc 1 students need to learn a little more arithmetic than you've had before, where you have a fraction that's 0 divided by 0. That's called indeterminant. 0 over some number is 0. Some number over 0, you can't divide by 0, it's undefined. 0 over 0 is indeterminate. New word. Let's talk about the conditions. Just going to make this a little bigger. Here's where we have a condition where we have 0 divided by some non-zero constant. Well, here we have 4/4, 3/4, 2/4 or a half, 1/4, and 0/4. We have a whole, in this case, divided into 4 pieces. Nothing has been colored. So that's equal to 0. But these are also equal to 0. This is 0/2, 0/3, 0/4, 0/5, 0/6. A 0 is, it is 0 pieces and any non-zero number in one whole. 0 over some number is found in everyday computation. It's just plain 0. You've been using it since you were in 4th grade, probably. Next condition. Some non-zero number divided by 0. That's called undefined. And you've probably heard it 100 times. You can't divide by 0. There's no computation rule, as one might find for fractions or logs, where you have computation rules to use, but division by 0 is not defined. Nobody probably has ever told you why. We're going to look at that in a little bit. Some non-zero number divided by 0 is probably first found in middle school when you were doing order of operation problems. What's that? Order of operations. Here's order of operations problem. Finally, please excuse my dear Aunt Sally. I'm sure you've heard of that. If you haven't, maybe you've heard of PEMDAS. Let's go back to where we are. Okay, we were here. We're going to scroll down again. We've talked about this. We're now talking about undefined. Okay, the first time you saw it was probably in middle school. And then you probably saw it when you talked about slope of a vertical line. Slope, rise over run, y2 minus y1 over x2 minus x1. Vertical line, there's a vertical line. Every single x value on the line is the same. The y values change. But this is a vertical line. Its slope is undefined. It has no tilt to it. If you were to walk from left to right, you couldn't walk through the line. Can't do it. So you were happy with this. I think you're now happy with that. Now we may go on to the next idea. We're still talking about slope. We're still talking about some number divided by 0, and that you can't do it because you can't divide by 0. Well, I'd like to look at 3 other conditions, 3 more instances of this same situation. If you've had algebra, that picture is some constant divided by x. And you probably know it as a reciprocal function. And as you get closer and closer to 0, the curve increases. That may be difficult to look at. So we're going to do it another way. We're going to use a limit geometry sketchpad. I already have it open, but you can click it and download it and keep it and edit it as you wish. I've taken the opportunity to change my function to 2 over x. That's what we're playing with today. And I'd just like to look at what the values of the function are as x approaches some constant. In this picture, we're going to approach 0. And I'm going to ask you, if you want to play on your own, download the sketchpad and then slide, approach. So as x approaches 0, the value of the function continues to increase. That's this picture and that technique. but I'd like to review division by zero, fractions with zero on the bottom, in terms of the definition of fraction we've already done. Here we're talking about two wholes and some denominator, some number of pieces in one whole. Here it's 10 pieces, we get 2/10. Here there are 9 pieces, 2/9. 6 pieces, 1/3. 5 pieces, 2/5 is 0.4. 2/4 is 0.5 or a half. Notice 0.2, 0.22, 0.33, 0.4, 0.5. The numbers are increasing as the number of pieces decrease. So we were up to 2/3. Now let's go to 2/2. Now let's go to 2/1. Well, what does that mean? That means one whole is a whole circle, but we still need 2 pieces. So we need to use 2 circles to make that. You may have a whole number of pieces, or you may have fractional number of pieces. We looked at that before. We looked at this problem where we had 2 divided by 3/5, where 3/5 was the size of 1. And we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/5 made up 2. So let's start over here. We've gone down from 10ths to 9ths to 6ths to 5ths to 4ths to 1/3s to half to units. Now we want to get even smaller, smaller sized pieces than 1. We want to increase the denominator. So now we're going to divide. Here's 9/10. Well, that's 1, just a little smaller than 1 is 9/10. A little smaller than that is 4/5, 3/4, 2/3, 3/5, 1/2. Too fast, too much. Let's slow down and look at it again. We decreased the size, we increased the number of pieces in one whole. And in doing that, we decreased the size of the piece. We increased the number of pieces and decreased the size, increased the size. Let's go back and just look at this again. We came in from a whole number of pieces, and then we're going to the fractional number of pieces. As you make the number of pieces in one whole smaller and smaller, the size of the fraction increases. Let's see if we can find one we were on. All right, so we have 10ths, but not all of them. 9/10 makes up one whole. And we need 2 of them, 2 wholes, 2 written in terms of tenths, 2 times 10 is 20. So we need 20 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 2 in terms of 9/10 will turn out to be 2 full ones and 2 out of the 9. If we use 4/5 as the size of one whole and wished to write 2 of those, 2 wholes in terms of fifths, 2 bunches of 5 is 10. Let's see if I got that right. No, 2 in terms of fifths. 1 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as we keep the numerator, the number of pieces, constant, but change the denominator, getting smaller, 9/10, 8/10, 3/4 or 0.75, 7.5, 6 2/3 tenths, as we make the whole number of pieces in a whole smaller and smaller and smaller, the numbers increase. When we get down to 9ths, 1/9 is a whole. 2 in terms of 9ths is 18/9. Turns out that's how much it is. You may not believe it, so let's do it one more way. Here's a calculator. If you wish, you may input some number for the size of the denominator, the number of pieces in one whole. So if I put in a 2 here, 2 divided by 2 gives me 1. Let's put in a 4. 2 divided by 4 gives me a half. Let's put in a 10. 2 divided by 10, 2/10. There it is, 2/10. Let's put in a small number now. Let's put in 0.5. That's only a half. 2 divided by a half is 4. Let's put in 0.4. 2 divided by 0.4 is 5. Let's put in 0.1. We get 20. Let's put in 0.005. That's close to 0. Think about where that is. That's like really here. Should be something really big. 400. And we're not even at 0. The goal is to figure out what that some number divided by 0 really looks like. We're not permitted to do that. It's undefined, but why is it undefined? Let's just put in 0. Now, we're working on an HTML page, a web page that has math functions built into it. So mathematically, if you take some constant and divide it by 0, it's infinitely large. The problem with that is there are a lot of different kinds of infinitely large. You can have just plain polynomial, which is the smallest of the infinities, or you could have just one more than that, polynomial plus 1, still infinite, polynomial plus 2, still infinite. So now we've gotten through just fractions as discussed, and they don't discuss it much in high school. All they tell you is you can't divide by 0 and leave it at that. But now you see that the reason you can't do that is because the value you get is infinitely large and cannot be written as a real number. Now we go to the Calc 1 material. Indeterminate, 0 divided by 0. Well, if you weren't allowed to divide by 0, now you got 2 zeros. It's called indeterminate. It's an expression, and there are a bunch of them. Each of these, it's what is called an indeterminate form. 0 divided by 0, 0 to the x, infinity, infinity divided by infinity, and so on. We're not going to talk about that. All I wished to talk about and discuss is 0 divided by 0 itself. Student probably sees this first in Calc 1. Here's where they would see it when they talk about special limits. We're going to go to that link. There we go. Okay, this is a page from my notes. I post my notes for my students. This comes out of Dr. Hartman's Apex Calculus. The writing team got a grant. It's an open source material. You can download it and have your very own PDF calc book. I've taken his special limits and examined them with respect to this idea of indeterminate. Indeterminate is when you have a 0 over a 0. So if your function is sine of x over x, the graph of the sine is 0 at 0. The line x is 0 at 0. The function value for this function is 0 over 0. That's indeterminate. The function is indeterminate, but the limit may be taken because you approach. Same with this function and that function and that function. And that's all we really had to talk about. So again, here it's linked. I put it in Calc resources, and all of that's available with the last button on the home page. Hope you got something out of this.